Hello guys, welcome again to this basic power system series. We have already completed six topics on this series. Okay, so let's start with the today's topic. So today's topic is comparison of conductor cost of transmission line. Okay, it's you can say it's a very important topic in power system as well as in electrical engineering. Okay, basic electrical engineering. Uh, okay. So there are different types of conductors are there. We'll just compare three system here. Okay, DC three-wire system, single phase two-wire system with one wire earthed, and three-phase three-wire star connected system. There are lots of combinations, 10 or 12 combinations. I think it's available maybe uh, commercially. So by doing all the only these three conductor cost comparison, I think you will be able to do the comparison for other conductors also. Okay, you will be able to calculate the cost for other conductors also. It's not actually 100%, it's only theoretically. Okay, and I would like don't try to remember everything. Okay, try to understand. It will be very easy if you understand it. So you will not face any problem while doing other. Suppose you remember all the calculations and all for these three conductor, but when you see in your exam or somewhere, if your teacher asks about the other type of conductor, maybe you will not be able to do it. So try to understand it, then you will surely able to do. I think so. First of all, we will assume that same amount of power is transmitted. Okay, same amount of power is transmitted. Otherwise, we will not be able to compare. Okay, if three system but three different types of three different amount of power is transmitted from one point to another point, so that will be like that will not possible to compare. So same amount of power is transmitted and same length of line, the length of the transmission line. Okay, conductor means the transmission line, or you can say same conductor length. Okay, then same maximum voltage to earth. Maximum voltage to earth is same. Okay, earthing voltage and same line loss. That means what I want to say here, the same load power. Okay, is the same. So first DC three-wire system. We'll see one diagram. Okay, yeah. DC three-wire system, total three conductor. Okay, you can see the first one. This one is one conductor. Okay, this one is it. Shall I need to highlight it? This this conductor is first. Okay, then there is another one, and there is the middle conductor is earthed. Okay, this conductor, middle conductor is earthed. When the load is balanced, the current in the middle line is zero. Sorry, okay. When the load is balanced, the current in the middle line is zero. Okay. Yes, right here. Erase it. Let me erase it. Okay. Now let's go to the calculation of this part of this square. So the current will be look here. I1, I1 current is suppose passing through this conductor. Okay. I1 current is I1 will calculate. Current is P by 2V. Okay. Why 2V here? P we know power current. P we know voltage into current. Okay. That one we know. I think it's like at starting it's basic thing. Okay. P we know P is equal to V into I. But here we are Writing it, so from here we can write I is equal to P by V. So, but here I is equal to 2 by, sorry, P by 2V. Because here in the graph circuit you can see three conductor, 1, 2 and 3 conductor. Okay. So here voltage V and here also voltage between these two conductor voltage V. So total voltage is 2V. That's why here 2V. Okay. Then line losses. Line losses we know loss I square R. Okay. Here resistance we are assuming it R1. So and I have two conductor, one conductor and two conductor, and the third this middle conductor is R6. So we will not calculate for that one. Okay. So 2I square, because of that two conductor I1 passing through this conductor, also passing through this conductor, and P load. Okay, P load is same for it will be same for all the wires. Okay, we are comparing three wire. So line loss we are denoting here with W. So 2I square R1. I square R, this is the loss. Okay, loss calculation. This one is I square R. I square R1 we are there because we are assuming the resistance for this this system is R1. R1 because it will change. Okay, R1 will change surely because it will different conductor is equal to, so is equal to 2 P square by 2 V square. Okay, we can write from here 2I square. Okay, I is equal to P by 2V. It will be I1. So 2I1 square. Okay, so we are just putting the value of I1 here and R1. So it will come as P square R1 by 2V square. Okay, it's clear now. And we know R is equal to rho L by A. Rho is the resistivity, R is the conductor length, A is the cross sectional area. Actually, we are comparing this cross sectional area. Okay, or we can say we are actually calculating this cost. We are actually comparing about this area, cross sectional area, or we can say the thickness of the conductor we are saying. Okay, that we are calculating here. This whatever conductor it will take more thickness. Okay, more area means it will take more area. That means cost will be more. Okay, we are calculating in this sense. We are comparing. We are going to compare the conductors in that sense. Okay, is it clear? Or I think it's clear. So R is equal to rho L by A. This is also formula. Okay, rho is the resistivity. Resistivity. L is the conductor length. A is the cross sectional area of the conductor. Okay. So line loss W is equal to, we are just putting the value of R in the place of R1. Okay. Rho L by A1. A1 it will be changed. It will be defined for different system. Okay, so the area will be, from here we can calculate A1 na, because we know here W is equal to P square by 2 V square into rho L by A. Okay, so area A1 we can write, just W will come in this side. Okay, right side, A1 will go to left side. Clear? Then we'll calculate the volume. This is the thing we are calculating, not the cost. Sorry, it was by mistake. So we are calculating volume. Volume we are denoting here with O1. So volume is equal to 2 into L into A1. Okay. Why we are putting 2 into L? L is the length of the conductor, same for all the conductors. Okay, there is one conductor, there is another one conductor. These two and these two is its middle conductor is offset. We are not, I'm not going to calculate for this one. Okay, because this one is offset already. We have specified here. So we have two conductors. Okay, that's why 2 into L. And we know the cross sectional area of this conductor, the same conductor, this one and this one, same cross sectional area and two conductors. So total volume we can calculate from here, 2 into L into A1. We are just putting the value of A1 here. Okay, this P 2 into L into P square by 2V square into rho L by W. And this total part, so okay, it will come as 2 we can cancel it out. Okay, P square rho L by P square rho L by V square, and it will come as square P square rho L square by V square W. Okay, and we are assuming this part as K. So we are just totally this part we are totally assuming as K. Okay, this will be P square rho L square by V square W. Okay, I'm going a little bit slow so that you can revise it. Okay? It will be better when you are understanding, trying to understand something. Going a little bit slow is okay, I think. Now another conductor that will be single phase two wire system. Another system that will be single phase two wire system. Okay, one wire is earthed. Okay, so let's see the circuit for this. This is the circuit figure 21, as you can see here. Okay, one AC source. This one is AC source. Okay, this one we are doing for the AC. This one is one first wire, and the second wire is earthed here. You can see. Okay, P is the same. P is the load. Okay, that's same power. And the resistance for this system is R2. Okay, and I2 current is flowing through it. Okay. So the RMS voltage to be earth is VRMS is equal to V by root 2. Okay, this is the formula for AC. VRMS is equal to V by root 2. So let I2 is the current. Here I2 is the current flowing through it, and cos phi is the power factor of the load. Cos phi is the power factor of the load. Cos phi is the power factor. I think you know it or not. We'll come with this power factor in the next lecture in details. Okay. Here we are assuming I2 current is flowing through, and the power factor of the sorry power factor of the load is cos phi. So I2, that same formula V, we know P is equal to V into I. Okay, from the same formula. Last time we have added in the place of V 2V because there are total three conductors. The middle conductor was active. Okay. Here I2 is equal to P by V, and V value is here we know we are getting VRMS cos theta. Okay, we are going to put VRMS cos phi, sorry, not theta, cos phi is equal to, we are just putting the VRMS value V by root 2 cos phi. Okay, clear? So now we'll calculate the line losses, that W we are denoting. W we are just denoting it. You can denote with anything else. Okay, we are denoting line losses W. So I square R, that same formula, 2I square because two conductor here. Okay, so we are just putting the value of I2. The same it will come 2 into 2. This is the value of I2 from here. Okay. 2 into 2 p square R2 by v square cos square 5. Okay. It will come 4 p square R2 square by v square cos square 5. Is it clear? 2 I2 value, this one, p by v root 2, okay, and cos 5. If it will come root 2 square, that means it will come root 2 square means 2 it will come. Is it clear now? So the W, we are going to put the value of R2, R is equal to, we know, rho L by A. Okay. That same formula, we are applying this first one, this formula, and this formula only, this basic formula we are just applying this calculation. Okay, we are putting the r value. This is r2, that's right, this will be a2. Okay, rho L by a2. So from here we are just calculating a2. We could have do this one by manually, but I have just put it all the equations already. Then I don't need to write it again. Okay, that's why I just write it down already in the PPT. Or maybe I could write this manually here, okay, during this lecture, during this making of this video. Okay. From here, we are just calculating the value of A2. So from here, it will come 4P, this A2 will come to the left side and W will come to the right side. Okay, same thing, everything is same. Okay, so volume. Now, finally, we are just calculating volume. Okay, and we'll see which one is taking more volume. Okay. So volume here, two conductor, one conductor here, another conductor here. Okay, two conductor. So that's why 2L into A. A is the cross sectional area. Here it will be A3. So 2 into L into A2 value we are just putting. From here we are getting this 8 by cos square 5 into rho p square L square by V square into W. And we know from the previous calculation, we have assumed that rho p square L square by V square W is equal to K. So we just putting this value, putting the K in place of this. So it will come 8K by cos square 5. Okay. Finally, area, volume O2 will come 8K by cos square 5. Okay, simple calculation. I think it is like not that much difficult calculation. Very simple, I think. Yeah. So for the first one, we got K. For the second one, second system, we are getting 8K by cos square 5. Okay. Now, three-phase system, star connected system. It's a AC system. Sorry. So here is the circuit. Okay. Three-phase star connected system. This is star connected system. Okay. You can see here in the figure 22, same load P. Okay. I3 current is flowing through it. Okay. And the resistance is R3. This one is neutral point. This one. So three-phase system, neutral point R set. This middle neutral point is R set. So the RMS phase voltage is V by 2. Okay. RMS phase voltage will be V by 2 and line voltage will be 3V by root 2. Line voltage is 3V by root 2. You have to see the basic star connections with the or. From here we are getting this. Okay. So RMS phase voltage is V by 2 and line voltage is 3V by root 2. So we'll first calculate the current flowing through it is I3. I3 is equal to P by that P, that same formula I'm not writing. Same formula P is equal to V into I. From there we are calculating I3 here. I3 is equal to P by VRMS cos phi. Okay, VRMS cos phi. We are just putting the value of VRMS. Okay, line voltage P by 3 V by root 2. We got it here also. The RMS phase voltage is V by root 2. So line voltage 3 V by root 2 because 3 were na. Okay. There will be three potential distance from here to here, this to this, and this to this. Okay. Three potential distance between the conductors. If you can imagine, okay. From this conductor to this conductor, one voltage. From this conductor to this conductor, one voltage. From this conductor to this conductor, one potential difference. That's why 3V by root 2. Okay. So we are just putting the value of this. So finally we will get P root 2 by 3V cos phi. Okay. So actually we'll at last we'll calculate a volume. So because of, for that we have to calculate first line loss W. Okay. Line loss, I square R, same thing. I square, we are putting 3. In the place of I square, we are putting 3 I3 square. I3 because of line, I3 current is following through this system, and 3 because of 3 conductor. Okay. 3 I3 is I3 square R3. R3 R3 is the resistance for this system. Now we'll just put the current value I3 here. Okay. P root 2 by 3V cos phi. We're just putting the same. Okay. Root 2 square, so it will come 2. Okay. That's why 3 into 2. P square R3 by 3 square 9. V square cos square phi is equal to 2 P square R3 by 3 V square cos square phi. Okay. Okay. It will come 3. Huh? So we know R3 is equal to rho L by A3. That same calculation, same formula. Okay. Now we are calculating W. Okay. Line loss is 10. So we'll just put the R3 value in the place of R3. Okay. Rho L by A3. And finally it will come A3 is equal to 2P square Y by 3V square cos square phi into rho L by W. And volume we have to calculate the total length into cross sectional area, total length, and the number of the first number of the conductor, then total length. Okay, length and the cross sectional area. So 3 into L into A3, it will come. Okay, we're just putting the value L. A3 value, we just put in simple this from here to here, we just put in A3 value. Okay. So finally it will come 2 by cos square phi into rho P square L square by V square W. You can check it. Okay. Surely it will come. Okay. Simple. P square is coming here, rho is coming here, L into L square. Okay. And 3 and 3 will go. Now V square W and cos square phi. Okay. And this value we know it's a K. So it will come here. This value we know it's K. So 3 it will come 2K by cos square phi. Okay. It's clear. We are calculating volume for all three systems. You can do same for all other system also. Okay. This one is for overhead transmission line. For underground transmission line, there will be no arcing. So you have to calculate one more conductor here. Okay. There will be no earthing. You have to calculate one more connector there. That's the difference. Okay. All this calculation is for overhead transmissions, overhead transmission line. Okay. In underground transmission line, what you have to do, there is no earthing. Okay. That will be earthing is where to where. Okay. So earthing again where to where. So by comparing the line losses, we'll just compare all three. Here, volume of copper or whatever conductor material we'll use. Okay, O1, O2, O3. These are the three volume we have just calculated for the first system. Three conductor, two middle conductor is earth, then two conductor. Okay, then three conductor, three star connected. Okay. So thus it conclude that DC three-way two-phase system is the cheaper on basis of conductor cost alone. Okay, because it's giving the less volume. Okay, you can see here K this one is 2K, and cost curve by this one is, if we divide it also with this, then it will not be greater than it will be greater than this K. Okay, Chilu. Cost is power factor. Maximum value is 1. Okay. So, but if we leave this DC system, this first one is DC system, we just compare these two. This one is three star connected, three conductor. This one is two conductor. Okay. Here, this value is giving the less volume. That means if we install this three-phase connection in overhead transmission line, we need less volume of conductor. That means it will decrease the cost also. First of all, this is the cheaper, okay, compared to other thing, because less volume. The same thing. If we install the conductor transmission line, then it will take less volume. That means don't need that much copper or aluminum, whatever we are using. That means it's reducing the cost. Okay, you got it? Okay. But if we compare only these two, then we can see this value is less than this value. Okay, surely. So it's cheaper. Three phase, three as AC, three star connected, three phase. That one is cheaper than the two conductors. Okay, two conductor AC. Is clear? If you still have any doubts, you can comment in the comments. I'm just trying to do it in more easy way. Okay, I think it's clear for you guys. If you still have doubts, you can comment in the comments. And if you want the calculation for other types of conductor, also you can comment. I'll come with the other calculation with the other conductor systems. Conductor means systems. Okay, different systems here we are actually comparing. So if you have any doubts, comment in the comment box, and I would like to request you to just subscribe this channel. And my humble request to everyone, please plant only one tree in a week or each Sunday. Okay, only one, because according to me, I think it's not according. It is the only thing that the only way to fight against global warming is plant tree. I think it is like that. We can't like fight rather than planting trees against this global warming. Okay, so it is my request. Just plant only one in a week or each Sunday. Sunday is holiday. If you are busy throughout the week, obviously you are free on Sunday. And PPT is available. If you want it as, if you want to keep it as note, you can request me to this email ID. Okay. And in next video, we'll be covering this power factor improvement, where we'll discuss a little bit about power factor also. Okay, and yeah, that's all. We'll be covering this all these topics of basic power system. Okay, so I would like to request you again, if you have come here for the first time, please subscribe this channel, because after completing this basic power system, will be coming with the advanced power system, as well as we are different types of small important topics videos we are I'm uploading continuously. Okay, so that's it, guys. Bye bye. Enjoy.